Well, I'm not here to talk about AI, so we can put that to bed here. We presented this before. NVMe Express has changed, at least since I've been a member, where they would never talk about things that were in flight. It's always after they were ratified. And recently that has been changing. As Adam said earlier today, things are going faster and faster and faster. There are things happening in parallel with the standard being developed. And so NVMe has already announced what I'm about to present today, and I'm just going to give you an overview. And it's host managed live migration. And as you look at host migration, everybody asks, what's the use cases here? And there's two typical use cases that we talk about. First is load balancing within the data center or in the compute farm. And so if you look at a compute farm, you could have a couple servers. I have different color-coded VMs running with their storage capacity using locally within the machines. And somebody can call you up and say, hey, I want to buy some space on your compute farm. And of course, that comes with capacity that goes along with that. And since we're here about NVMe, I won't talk about the compute side, but let's talk about the capacity. They call you up and say, I want to give you cash, and let's go. And you look at your farm and you say, well, it doesn't fit. It won't fit in any of my servers, and so what do I do? And so what you can do then is, well, what if we start looking at moving that workload around from one server to another, and then allowing that new capacity and that new cost structure coming in to come in and run. I call this a cash cow, okay? This is immediate cash. And if people, you know, if you really think about it, you call me up, you're going to pay me for a service, you're going to give me cash now, I move things around and I get money now. The other thing that we look at in terms of the use cases is, maintenance. And it's a big issue. I used to work for HP, now HPE, it was a long time ago. We built servers, they didn't go down for a long time. So really from a day-to-day perspective, you know, maintenance is there, it's important, but the day-to-day is more, what are you going to do live, keeping your workloads there. But maintenance is important. So let's say you have a couple servers in your working, and you have a problem and you want to do maintenance with a server on the left, and you got to say, well, I got to bring it down so you can start moving your workloads over. One of the things about live migration that we really felt was important is we wanted to be able to move multiple migrations in parallel. We didn't want to limit it to one at a time. So as I go through this here, please think of it as I may be showing you one VM in this presentation, but the intent is it's very scalable. Also, what you're going to see here is when I say a controller, it's any controller. It could be a physical controller. It could be a virtual SRIOV controller. It doesn't matter. It's just a controller. It's a capability that NVMe is defining. This button doesn't work really well. So as we look at it, there's really two things. This is called host managed live migration. It's about the host doing the bulk of the work and going out to the different servers and the controllers and saying, I need you to do an operation so I can orchestrate the whole migration of the NVMe over. And what it means is I need to go get the NVMe state associated with that VM I'm migrating and move it over. And that state has two things. It has the namespaces and it has the actual controller itself and the internal state of that controller. And then when you go to put that state in the other server, there's got to be services to put that state in and to tell it to run from the state where it last left off. So what I'm going to do is I'm just going to look at the individual services and try to focus on that. So we got to look at the source system first. And the first thing that we're going to do is I have a server running. It's got a hypervisor that's controlling everything. And what we're going to do is if I say the controller managing the migration, it's the blue controller. And if I say the controller being migrated, it happens to be a controller associated with a VM that's being part of the migration. Okay, got to get that clear because we just have controllers and people like names and don't like names. And in the NVMe, we're arguing over stuff like that. But anyway, I have this VM in purple here, and it's got a namespace, and it has allocated resources in there in the capacity. Because you could have a namespace, it could have a terabyte of capacity for that namespace, but you could have it half filled, and that half filled is called the allocation. Okay? So what you need to do in terms of migration is I need to read a static condition of the state and move it over. Then I need to track all the changes that happen from that static state and move it over. And then finally pause everything, move over the final state, and then say go. Because it's just, as you go through iterations of this, you can go, but you need a static state. Well, for the logical blocks, you need to be able to read what's allocated, okay? Because you just don't want to copy the entire namespace. You actually want to just copy what's actually written to the namespace. So what we have done as we've done live migration in NVMe, we're finding that it's actually multiple TPs that give you different capabilities. If the host uses them right, they can do what they need to do for live migration, but we've been able to break it up into smaller pieces and make it more manageable. So we have ratified one, and what it does is it allows the host to come in and say, hey, tell me what's allocated, so I can send down a new command. Now, I'm not giving you the commands, because when we ratify, we'll do all the final commands. So I can just do an overview at this point here. So in the future, when it gets ratification, more information will come on the actual commands. What the controller does is it goes out there and it's able to report the actual LBAs that are allocated. In this case here, this is already ratified. The report that comes in happens to line up to tell you a starting LBA in a range that the host could then turn into I can go do read of that namespace, I can copy it over to the other server and do writes over there, and I can move the static over there and not have to compute a lot of stuff because NVMe is going to tell me everything I need to do. And we also found that, wow, I don't need this just for live migration. What if I'm doing snapshotting? Before, I had no way of knowing what was allocated. So for snapshots now, you can use this capability to say, hey, I just want to copy what's allocated. I don't need to copy over the whole namespace. I don't have to manage it myself because NVMe will tell me what's all there. The next one is, I talked about, now you have the static capability for reading the static state. Now what we need to do is, how do we watch for any changes to those LBAs while I'm migrating over that static state and we can keep them logging? This is what I'm showing you here is a use case for PCIe locally attached capabilities. And the first thing we're going to do is we're defining the ability for the host to create what we're calling a migration queue. Okay? This is where the controller now is going to be able to write into that migration queue and tell them what LBA's changed, and we're going to walk through that scenario. Once the host actually allocates the memory there, it can then send down a command that says, hey, controller, create a queue. This looks very similar to an I/O completion queue. Very similar, same kind of semantics. And when that track comes down, now the controller that's managing understands that there is an association between the migration queue and the controller that's going to be migrated. It also knows where in memory, in the host memory, that resides. And there now I have a head and tail pointer, just like you would for an I/O queue. Then now the host, the hypervisor, can come in and say, start logging that namespace on the controller. And now when an I/O write comes into that, through that VM and gets posted and gets allocated into the namespace, the controller can then say, at some point in time, go out and say, I need to go through the controller managing and populate that LBA change into the queue. And when he does that, the tail pointer is going to go down because the controller has the tail pointer pushing items at the bottom of the queue. And then finally, at some point in time, the host can come in and say, I've taken that changed, I've used it out of the queue. It can send down a command that says, hey, change the head part of the queue. That element comes off, and we've actually populated the whole queue. Okay? Now I'm just showing you one at a time. This could be lots of them. What you're going to find is that population of how the controllers are pushing this data up to the LBA migration queue is left up to the controller. There's not a lot of requirements because they could aggregate data, not aggregate data, or whatever they need to do to be efficient. NVMe is just saying, here's how you can send the data up. Okay? Then there's another thing that's actually coming from a use case of a DPU where you have DPUs emulating the controllers, and in this case, they actually may be using NVMe over fabrics for the namespaces, so they may not need to copy the namespaces, but they want to track the memory changes that happen in the host during the live migration. Okay? And in this case, what happens is you come down and you say, start logging memory changes, that is the purple controller, the controller being migrated, if he does any NVMe command that affects the VM's host memory, I want him to remember it, and then I want you to tell me what if any changes have occurred. Then when an IO read comes in, for example, and the namespace is read and we move that data to the VM, the controller that has somehow in the NVM subsystem, you have to remember that that transaction happened. Okay? I'm not getting into any implementation details about how the control or how the whole NVM subsystem does it, but you have to remember that for this controller that's being migrated, that you asked for this tracking, that he just wrote to the VM memory over this range, as long as that range was included in the requested ranges to be tracked and monitored. Then the controller can get a command, the controller that's managing the migration can get a command from the hypervisor that says, please report to me memory changes that happen, and he'll send them a report of the memory changes that have happened. And then the hypervisor can use that to say, hey, I got these changes for the VM. Because you understand, I'm showing you how NVMe, you can move the namespace over in the controller. The hypervisor still has to move the VM itself over to the other server as well. I could imagine they're taking a static view of its memory and dynamic changes and moving them over as well as they go along. This button doesn't want to work all that much. All right, or I'm not pushing it hard enough. Okay, wrong button. All right, the next one is you have to have the ability to read the controller state of the controller being migrated. So there'll be a command that says, go get the controller state. And when the controller state comes back, it's actually going to provide two pieces of information. One is NVMe state that we're defining by NVMe. And then there's also going to be a way to do vendor-specific state, because you're going to have vendor-specific capabilities, and then they can define what state goes across there. There's going to be an interface to uniquely identify them, but the contents of them are outside of the NVMe specification, but we're allowing this to be adaptable. Hopefully in the future, these vendor-specific stuff eventually turns into NVMe state, so it gets more open about what is and interoperability, but we have to allow for differentiation and for experimentation as well. So now I have the state, I've moved over the namespace. Now what I need to do is pause the controller from operation. So, sorry about that. Let me go back. All right. I got ahead, I pushed the button, I didn't mean it. So you can send down a new command, goes over and pauses the controller. And what that's going to do is that controller is going to pause fetching commands from the submission queue, complete all of the commands that he's fetched, and be done, and he's not processing commands. The IO queue still exists in host memory. The host could actually, the VM could still even be running at this point and posting commands into the queue, but that's up to the hypervisor to deal with all of that. I would assume that he probably pauses the VM before he does that, but from a NVMe controller point of view, once it's paused, then no more additional work is happening. So now what can happen is you can come in and you can get the state and move it around. So now let's go look at the other side of the equation, and that is on the target system. So on the target system, you have a system over there, and I'm assuming the controller that we're going into there is in a state that it's not being used. It may be paused, okay? And it's just sitting there waiting for work. Now, I already have the namespace here, because as we talked about, he could have already created the namespace on the other side and it exists, or he could still be moving the changed LBAs from here, but I'm assuming that the namespace was already done, and that is that this hypervisor created the namespace and copied all the data by talking to the hypervisor on the other side. So the next thing we have to do is take that controller state and push it into this controller, and so now he has the same state that was on the source server when we had him. So that's why he turned purple. So he's sitting there, I've just loaded the state, I have my IO queues all set up, they're all pointing to where it was, where the VM was, and I'm ready to go. However, what that means then is now we have to get to the final part, which is resume. But before we resume, it is the host's responsibility to get that VM fully migrated over there, because as soon as you hit resume on this controller, he's going to start fetching commands and start processing commands. So I'd assume you want the VM up ready to be processing all those completions. So when a pause command comes in, it'll just come in, unpause him, starts fetching, and we've migrated that VM over. Now what I'm not showing you is on the other side, you just reset that controller and you can use them for something else. I'm not going to show you those level of details here. We just want to give you a high level view. One of the things is to understand that the controller that is managing the migrations is getting all of these new commands, but he needs to understand what's happening in those controllers that are being migrated in terms of being able to understand what logical blocks are changing and everything to report all of this information. Okay. Right now, we're leaving, the expectation is that the hypervisor that's moving the namespace will use normal read and write commands to get to the namespaces. And one thing is because it's host managed, the host is responsible for all the transmission of this data from one server to the next. NVMe doesn't do anything across multiple communications across multiple NVM subsystems. As far as I know, I don't know of anything that does that. So that's out of the scope of this specification. That's why we named this host managed. We want to make sure people understand that NVMe is just providing services to do this live migration operation. I expect that this should be ratified by the SNIA SDC. I'm going to put in a talk where I'm hoping to get enough time to actually walk through all the details of all the commands and everything else and resets and all the stuff that goes along with that, which I'm limited by the NVMe board of directors from exposing at this time. So that's where we are. That's the end of my talk. I probably got us back on schedule. Any questions? I'm so good at nobody has questions. Huh?
By the way, I want to bring it to SNIA SDC
Oh,
also.
sorry. I'm dyslexic. I didn't even see that. Yes, Paul.
Yeah, Mike, so I wanted to point out that when you are migrating the contents of the source namespace over to the other, those reads are being done by the managed controller, not by the migrating controller.
Everything is transparent to the VM. The VM
Yes.
shouldn't be seeing anything
Nothing
from
at
this
all.
at all.
Right.
Correct.
Okay, very good.
And
Want to
how
make sure
that-
everybody
yep,
knew that.
Yep.
Which means that managing controller can't be an admin controller.
Managing controller cannot be an admin. What is an admin controller?
Administrative controller can't issue reads or writes or get LBA status commands.
Correct. He has to be able to do I/O commands. So in NVMe, there's an admin controller that is not allowed to do I/O. Administrative controller, not an admin controller. That's where you. So an administrative controller can do pretty much basically admin commands with no I/O capabilities, but an I/O controller can do admin commands and I/O commands.
And so you have to support namespace sharing as well.
Yes, absolutely.
We need to make sure we say that.
We've already talked about that. Yes.
I just
Wait. We got microphone here. One after the other.
just wanted to check that this will all apply to NVMe over Fabric as well.
Right now, the TP is tied to focusing on PCIe infrastructure mostly, but there's no reason why it wouldn't work with NVMe over Fabrics. However, some of the memory stuff that's done, it's a little hard to do memory transactions in NVMe over Fabrics, but the logical blocks could be done. However, you can't post to the host memory for the logical block changes. So that couldn't be supported. But in terms of getting controller state and putting controller state, that possibly could be done. But our focus was on PCIe use case for now. We're hoping that if NVMe over Fabrics needs some additional, they can add additional features later on. Okay.
Hi, I assume that it's logically implied by what you said that that those two controllers, if they're going to be using vendor-specific stuff, have to be from the same vendor. I assume is that right?
What I'd like to say is if a host wanted to define vendor-specific stuff in a manner that could be shared with multiple vendors, then that could be done outside the NVMe standard. So there can be ways to do that outside of NVMe, and in some cases, they may not want to share that, then it would have to be the same company, yes.
Okay, thank you.
So I don't know if you've addressed this, but are those controllers required to be PFs, VFs, both PFs, both VFs?
Any NVMe controller. So an NVMe controller will say, I support doing the administration of managing migration within the systems, and other controllers are going to say, I'm migratable, okay? Those controllers that say, I support the commands to do all of the controls, then you could use them, and they could be a primary controller for SRIOV, or it could be, you could have multiple physical functions, and one of them could be the one that says I can control, or you could have multiple of those.
But they must be in the same subsystem.
They have to be in the same subsystem, yes. Does that make sense? We're not trying to tie it to SRIOV or not. It's just a capability of the controller, and a controller can either manage or migrating. We're not supporting migrating the guy that does the managing, though.
The reason I was asking is because there are some specific implications with PFs and VFs and the security related with what can manage which controllers.
Understood.
Right. So is this kind of make one of the controllers more able than the other, and what does that mean?
The answer is going to have to be yes, because I would suspect that the different controllers will support different capabilities. There is a supported commands and effects page. So a controller that supports these new commands will say it's in my list, and these other controllers that are migratable, it won't be in their list. Now, you could have two controllers in the NVM subsystem that says I can manage migrations if you wanted to build a system that way. NVMe is not going to dictate how you build your NVM subsystem. They're just going to say, here's controller capabilities. You decide what controllers you build are going to be there. Right now, we are going to say that for, I was going to say for SIROV secondary controllers, we're not going to allow them to support these commands. They can only be migratable controllers, okay?
That clarifies.
Okay.
I have three questions. Well, the first is I want to answer the question that person behind there asked. You can't, I know from the cloud side, you can't migrate from an AMD system to an ARM system. So in terms of migrating from light systems, the cloud side doesn't do that. They don't migrate because the opcodes are different. So that would just an answer. My question is, since it's host managed, what makes it NVMe specific? That's my question, number one. Number two is the pause. When the controller being migrated is paused, do you define how long that pause is allowed to be before the network times out?
Before the network times out. Well, first of all, if you pause the controller, I'm assuming the VM is paused. So the
okay.
VM is not running at that time, okay? So, but let's look at it from an NVMe perspective. We don't know what's happening on the host side. So that hypervisor that I had in my diagrams, it has to be really specific about how to control all of this to make sure it works. So if you pause a controller and you left the VM running there, he could run into a state where his commands aren't getting done in a timely fashion. And that kind of stuff has to be orchestrated by the hypervisor to do this in an orchestrated way. Because NVMe has no clue what's happening up above the protocol and above the PCIe or the over NVMe. We have no control over that, okay? Well, NVMe is going to define a way to pause a controller. About when to pause it in relation to the migration and what effects it has on the VM, that's up to the hypervisor. They're the ones in control of determining when that is. If it was me, I would pause the hypervisor before I pause the controller. Then when he gets redone, if any commands that were completed beforehand, they'll be moved over. He'll see those completions, and he can go on from there.
Migrating the VM Migrating the VM is independent of migrating the NVMe piece of it. The NVMe piece is just the storage. So migrating the VM, That's going to be, yes, you got to have the same architecture, CPUs on both sides. You got to have the same, it's the hypervisor that's going to be responsible for making sure the VM is capable of migrating to some other destination.
Yep.
So this is just the NVMe piece of that. It's not the VM piece of
Right.
that.
Yeah, so it all goes to the orchestration part that you're talking, right? Because today, live migration or migration is a shared storage scenario where, the storage itself is not migrated because the data is there, right? Across multiple hosts. You just migrate the VM. So in this case, you would need to have either the same namespace in
Both locations.
target and
Yep.
destination, right? So you have this management point where out the end, it will be one VM per namespace.
Or always a one-to-one relationship of a namespace to a VM.
Yeah.
But a VM could have multiple namespaces
Correct.
if it wanted, but not technically shared with other VMs.
Correct, yeah, because you want just to move.
But the way
that
we're
part.
doing it at NVMe, hold on, let me finish here, Riverbed. He's a big NVMe guy over there. So in terms of NVMe, we're allowing you to say, I have two VMs sharing a namespace. You can migrate both of them at the same time. There's nothing prohibited at the protocol level. The host is managing that. So it could say, hey, track these things on these two hypervisors talking to these two controllers and give me on one side, give me the changes that are happening to the LBAs by both, and I migrate them both, and I pause them both, and I migrate them both over. There's nothing in NVMe that's managing that. That's all up to the host to decide what his platform looks like, how he's using VMs. And that's why when you say, well, that's why I just say controllers in my diagrams. We don't care
Sure.
what the controllers are. We don't care who they are or how they're interfaced to each other.
So the data transfer and memory transfer, you use the same fabric they use today. So you need to increase the bandwidth.
But you bring up a point that I didn't talk about. If I had two VMs talking to the same namespace, right? The host will tell both of those to track the LBAs on both sides because we're only tracking the LBAs affected by those VMs independently of each other. So he would have two LBA migration queues that are being populated independent, and he would have to manage that.
And this tracking is enabled by default or could be per namespace?
It's per controller.
Per controller, so a controller will track everything or not?
Yep, all the
Okay.
namespaces that are attached will be tracked.
Okay.
Okay.
Okay. Yeah. So it'll be interesting later on if you could use something like SDXI to do instead of using the same fabric memory and just to do some type of offloading across some of the devices.
Talk to the host guys.
Yeah.
All right. Thank you. All right, thank you.